For example number 10, when I first read this, I was a little bit confused on the interpretation. So let me give you what I think they're trying to describe here. It says a race car travels 1/4 of a mile in 6 seconds, meaning that I don't know if you've seen those sprint races, but let's say there's like a vehicle. Okay, here's the long track. Okay, and here's the finish. So the vehicle starts here, and then it takes off down this track. Okay, and the total length of the track is 1/4 of a mile. And if you want to know what that is in terms of feet, because it's actually not a bad idea since we're discussing feet here, a mile is 5,280 feet. So if we multiply that by 1/4, or I guess probably the best way is just to divide that. Divide it by 4. So 5,280 divided by 4 gives us 1,320 feet. So that's equivalent to 1,320 feet. And the race car travels this in exactly 6 seconds. So it's like one of those sprint races, right? They accelerate here, and then once they hit the finish line, and then you see those like parachutes or whatever, really slow down the vehicle. I'm sure you guys have seen that on TV before. So that's the situation that I believe is what they're trying to describe. Now what they want to know is once the car hits the finish line down here, they want to know how fast is it traveling and what is its acceleration. Okay, so its speed, its velocity, okay, its rate of change of position, okay, which the position is given by f, with respect to time, that is f prime of t. Okay, so we want to know it at 6. So I'm gonna evaluate these guys at 6 in a second here. So let's take the derivative of this. The derivative is 2 times 44 over 3, so 88 t over 3 plus 132. So this is going to give us feet per second. Okay. And so if we go ahead and we evaluate f prime at 6, we'll get 88 times 6 over 3 plus 132 feet per second. And so 6 divided by 3 is 2. 2 times 88 is 190. No, that seems too high. 176, sorry. 176 plus 132, which gives me a total of, I believe, 308. And again, that's feet per second. It's just interesting to see how fast that actually is, because feet per second, who knows what feet per second is really like? Let's convert that into miles per hour. I'm just curious. Okay, so 308 feet in 1 second. So we know there's 5,280 feet in 1 mile. And we want to convert that to hours. So we know that there's 3,600 seconds. I meant to write an S there. In 1 hour. And so if we take 380, we multiply it by 3,600, and then we take that number and divide it by 5,280, we get that it's traveling at 210 miles per hour. Now that number you can picture. Okay, 308 feet per second, that doesn't really mean a whole lot to us, but 210 miles an hour, that should mean something to you. Okay, so that's how fast it's traveling. Okay, that's its velocity. Now let's go ahead and find its acceleration. So the acceleration is d squared f over dt squared. So we have to take the derivative of f prime. So basically I'm going to take the derivative with respect to t of the derivative with respect to t of the original function, which was 88, oh excuse me, it wasn't 88, it was 44 t to the third t squared over 3 plus 132t. And so we already know what the first derivative is of this guy. That's this right here. So there's 88t over 3 plus 132. And when we differentiate again, we just get 88 over 3. And if we take 88 and divide it by 3, that gives us our acceleration, 29.3 feet per second squared. So the acceleration of the car, now I can't plug in 6 anywhere, okay? So it has a constant acceleration, okay? The acceleration is the same. It had a constant acceleration throughout the track. Its velocity changed, but its acceleration was constant at 29.3 feet per second squared, okay? I really don't have any reason to convert that into miles per hour squared, so because that unit of measurement is really not that familiar to you. So now let's take a look at B. So part B asks us to find how fast the car was moving halfway down the track. So how fast, its velocity is what it's asking. How fast was the car moving halfway down the track? Now here's the common mistake that's made. Students assume that it took me 6 seconds to travel this distance, so halfway down the track must be 3 seconds. Well, that's not true because the car's accelerating. Car has a constant acceleration, so its velocity is changing throughout here. So it's clearly traveling much faster over here than it is over here. It's not a uniform velocity. If the velocity was the same throughout here, then we could assume this, but the velocity is not the same throughout there. The velocity is changing. So the car actually doesn't reach halfway at 3 seconds. It reaches halfway at a different time. We need to figure out what that time is. So what we can do is we can use, there's a couple ways that we can do this. What I'm going to say is this. Halfway down the track is an eighth of a mile. Okay, so what I'm going to do is I'm going to go ahead and calculate the halfway point on the track to see where it's at. So the halfway point is an eighth of a mile, which is that 1320 feet divided by 2. So 660 feet, let's draw the track again. Here's 1,320 feet. Here's 660 feet. So halfway down the track is 660 feet. So let's figure out what time that occurs at. What time does the car reach halfway? That's the question I want to answer, is what is the time value here? Because if I know what the time value is, I can go back to my velocity function and I can plug in the time and it'll tell me how fast it's traveling at that time. Okay, so how long does it take the car to reach 660? Well, we have a position function. So I have I have f of t is equal to 44 t squared over 3 plus 132 t. That's the position of the car. We want the position to be equal to 660. So the question is, what is the t value? So what we need to do is we need to solve this guy right here. So let's go ahead and do that. I'm going to multiply everything by 3 to clear my actually I don't even have to, well, it's not a bad idea. Let's just multiply everything by 3. So 132 times 3 is 396. So 44 t squared plus 396t is equal to 660 times 3, which is 1980. So this equation is the same as this equation right here. Now let's move everything over. So to solve this, remember, it's a quadratic. So your goal in solving a quadratic, we usually can't get the variable by itself. So what we're going to do is we're going to bring everything to one side, and we're going to try to factor. If we can't factor at that point, then we're just going to go ahead and use the quadratic formula, or we'll complete the square. But the big idea here, the important thing, and I hope that you get out of any math course, is that if you're going to try to solve a quadratic, one of the techniques is to factor and have it equal to 0, because then one of these guys is 0. That's your zero product property. Okay, so let's go ahead and move everything over, and then we'll try to make life easier for ourselves by seeing if there's a common factor. So first thing to do is try to pull out a common factor. So let's see here. Is 396 divisible by 44? Yeah, it is, by 9. And let's say is 1980 divisible by 44? And yeah, it is 45. So if I divide everything on both sides by 44, my equation still balances, and I get the following. I get t squared plus 9t minus 45 is equal to 0. So now let's try to solve this guy. Now, one of the techniques for factoring is to take the 45 and see what its factors are. So 1 and 45. 2 doesn't go into it. 3 does, because 4 plus 5 is 9, and 9 is divisible by 3. So 3 goes into 45, I believe, 15 times. Okay, 4 doesn't go into 45. 5 does 9 times. 6 doesn't, 7 doesn't, and 8 doesn't. And then I'm back at 9. So these are my only options. Now the question is, do either of them add or subtract to give me 9? Are any of them going to give me 9? And the answer is no. So this is not going to factor out nicely by hand. So what we'll do is we'll use the quadratic formula. So we'll say, okay, negative b plus or minus the square root of b squared minus 4ac all over 2a is equal to the t value that we want. Don't say x, because there's no x here. Okay, it's equal to t. So negative b plus or minus the square root of b squared, which is 81, minus 4 times a times c all over 2 times a. That's the t value. Okay, so when we go ahead and we compute that guy out, guys, this ends up giving me t is equal to, let's see here, it should give me two answers here. Okay. Let's see, when I calculate that out, I think we get negative 12.58, and t is equal to 3.58. Now, once we get these two answers out, what we want to notice here is that the t value is clearly positive. It's not negative, right? Okay, so negative doesn't even make any sense. So the guy that we're going to pick is this guy right here. Now notice that the car reached halfway down the track, not at 3 seconds, not at half the time. Remember, it took 6 seconds to get all the way down, but it took 3.58, more than half, to get halfway down. And that should make sense, guys, because its velocity is increasing over this section. So what we're going to do is we're going to take this value, 3.58, and we're going to figure out what the velocity is at 3.58. So the velocity is a function of time. We know what that's equal to. That's equal to this guy right here. So we'll take 88 over 3 t plus 132, and we'll evaluate it at 3.58 seconds. So if we do that math out there, we've got 88 divided by 3, multiply that guy by 3.58, and then add to that guy 100 and 32. So we're going to end up with approximately 237 feet per second. And again, if we do the conversion for that, I won't do it out, I'll let you do it, but you end up with that being equal to about 162 miles per 1 hour. Okay, so that's how you go ahead and you solve that problem.